Welcome back to our ongoing discussion on inverse trigonometry. So far, we've got Arccosine set up. I mean, it's not perfect. It's not going to give us exactly the right position on the unit circle because, well, it can't. We can only do half of it. And that's going to be fine enough, as we'll see as we work with these over the semester. So let's go from there into Arccosine and then Arctangent. So Arccosine is going to have a very similar problem to what Arcsine did. So we'll keep the line of symmetry there, and here is Arccosine. Well, here's cosine, right? If I were to invert this straight up, or try to anyway, I would definitely not have a function. This is not a single function. If the input for 0 were this thing, I would have infinitely many outputs. That's not a function. But if I were to restrict the range of cosine to something smaller than that, maybe I'd be okay. Now the dream would be able to have the same restriction that we imposed on sine, specifically to go between plus or minus pi over 2. But if I were to do that, you see, if I were to go between plus or minus pi over 2, I would still not have a function after the inversion process. I still, on just this thin sliver, fail the horizontal line test. So I can't use the same restrictions that I used previously for Arcsine. So the convention is, instead of going between plus or minus pi over 2, because that doesn't work, instead to go between plus or minus, actually nothing really, to go between 0 and pi. So plus or minus is out now. Instead, we are just going to go between 0 and pi. We'll restrict the domain to that. And in doing so, we have then effectively restricted the range of Arccosine so that it is still a function. So that is the graph of Arccosine, if you ever needed to see that, which you almost certainly will not, but there it is. In words now, this is how we have Arccosine defined. It has domain, same as sine, right? Same as Arcsine. It takes everything that cosine could be and gives you a value that produces that cosine, but only on the range of 0 to pi. So whereas Arcsine gave you something in these two parts, Arccosine is only going to give you things in the first and second quadrants. And that's going to be good enough. We will see in this course that that's going to be good enough. We will be able to go from there and fill in the gaps, fill in the ambiguous case ourselves. Let's see, do I have some examples here? No, that's straight to Arctangent next. So for instance, let's say I asked, what is the Arccosine of negative root 3 over 2? You would have to ask yourself, okay, well, I need cosine of some number to be negative root 3 over 2. What is that number? Specifically, what is the number out here from 0 to pi? And there's only one such number, and that one number is 5 pi over 6. Not negative 7 pi over 6. I know that produces the same position, but since Arccosine has a range from only 0 to pi, Arccosine has outputs that are no bigger than pi and no less than 0 while we're at it. So that's Arccosine. And we got one left here, and that's Arctangent. And it's going to be the case that it's going to look totally different, but at the same time we'll have it defined much like how we have Arcsine defined. Let's see here. Here's our boy, tangent. And yeah, that's obviously not going to be good enough. Because, well, the inverse of that, if you would call it an inverse, is not a function. But if I took just this one centermost spot, this one centermost swoosh, then that alone is invertible. And that produces arctangent. So restricting the domain of tangent to plus or minus pi over 2 gives us arctangent, which means the range of arctangent is plus or minus pi over 2. And by the way, you actually might want to hold on to this graph. Arctangent is kind of cool. It's kind of useful, and will pop up kind of some It'll pop up some in calculus courses. It's a topic of conversation. And we'll get to that in future semesters, I guess. But so we have it defined now for all three of the inverse trigonometric functions. Our arctangent now has any input, right? Because our outputs for tangent could be anything. Right? Tangent can have outputs of anything, which means arctangent can have inputs of anything. But the range of values, the range of angles, the range of positions that it'll give you is only things in the first and fourth quadrants, specifically with values between plus or minus pi over 2. So that gives us this table now. And this is something that we're just going to have to remember, I'm sorry to say. And I know it's a little daunting to have to remember all the facts that we have to remember in this course, but at the same time, remembering also that I'm not making you memorize quite everything, and actually not nearly everything, doing this much is not quite that bad. Right, so Arccosine, actually, once you understand what you're looking at, it's not that bad at all. Right, Arcsine and arctangent gives you values in the first and fourth quadrants. So arcsine, arctangent gives you these guys, and arccosine gives you these guys. And that's pretty much all there is to say about it. Once again, though, just to say this one last time, it will only give you one position on the unit circle. It'll only give you one angle. There's two positions on the unit circle having the same sine value. There's two separate positions on the unit circle having the same cosine. There's two different positions on the unit circle having the same tangent. That's okay. Even though inverse trig will only give you one position. Specifically, for arcsine, arctangent, one in this position, and arccosine, one in these, never on the other side. That's okay, because we can use symmetries and we can use old-fashioned logic to deduce where the other position is. And that's something, once we get to that problem, once we come across that issue, and we will this semester, once we get to that issue, we will figure out how to address it. So, that's pretty much it. Right now, it's simply asking ourselves, on this semicircle, or on this semicircle, what value do I need to get the output I've been given? And also, just for funsies, right, you can treat this as an operation. It's an operator, because it's functions, it's well-defined. So if you were to have the arcsine of a sine of something, you would do it just the same as you would do any other order of operations. First you find this sine, which is a half, and then you find the arcsine of that, which is now pi over 6. So we'll play around with this in the days to come, and then we will do just a little bit more on angle measure, and that will round out the first unit. So let me know what issues or questions you have right now, and I will see you in class. Have a good one.